In this video, we're going to look at the graphs of our new functions, logarithms. Alright, so remember the logarithms are the inverses of exponentials, and the thing we learned about inverses, all they do is flip the points. Alright, so a comma b is on my exponential graph, then I just flip that point, BA has to be on the graph of a logarithm. Right? Logarithms seem like this more complex thing, but again, they're still just inverses, so this thing that we learned about inverses, just flipping points, still applies. Alright, so we're going to use the graph of 2 to the x to graph its inverse, log base 2 of x. So 2 to the x, what did we learn? We learned it has a horizontal asymptote at 0, y equals 0. Alright, again, normally we put this as a dotted line, but it's just quicker on the video for me to make it a solid line. And then we know the points, 0, 2, 4, 6, 7, 8, 16 right up here. We know it kind of gets really low and basically like a flat line to the left, and then it does that turn and starts getting big pretty quickly. All right, so that's our exponential graph. And now we want to graph our logarithm. Again, remember all logarithms do is flip the points. All right, just to kind of not make it a little confusing, I'm going to erase the horizontal asymptote over here. That way it doesn't interfere with our other graph. All right, but now let's graph the logarithm. So the point 0, 1 is on my exponential, means the point 1, 0 is on my inverse logarithm. 1, 2 switches to 2, 1. 2, 4 switches to 4, 2. 3, 8 switches to 8, 2, 3, 5, 6, 7, 8, 3. That's right, I'm just flipping all these points. 4, 16, which switches to 16, 4. 1, 2, 3, 4, 10, 11, 12, 13, 14, 15. So 16 would be here. We have a dot about there, would be on our logarithm. And then we could do this to the left as well. We had negative 1, 1/2 would become 1/2, negative 1. Negative 2, 1/4 would become 1/4, negative 2. Negative 3, 1/8 would become 1/8, negative 3. And you can kind of see what's happening. Negative 4 becomes 1/16, negative 4. All right, so this kind of red line going to the left is actually going to turn into a red line going up and down. And then the logarithms basically become a straight line here, almost a straight line. Again, nothing's actually a straight line. And then it curves up like that. All right, so this is my graph of log base 2 of x. All right, so the horizontal asymptote here is going to flip, and we're going to learn this called a vertical asymptote. All right, so we have this vertical line to get really close to, and it just kind of does the opposite of the exponential. So the exponentials kind of turn and shoot up really quickly. These turn and kind of go really slowly. This one I'll do a bit quicker, just when we have a smaller base. All right, we know for our exponential is going to look something like this. All right, it's going to be big to the left and small to the right. It levels off over here. I put that a little too low. Levels off there, and then it gets bigger as I go to the left. All right, so this is 1/3 to the x. We flip this to our logarithm. 0, 1 becomes 1, 0. Negative 1, 3 becomes 3, negative 1. Negative 2, 9 becomes 9, negative 2. 3, 4, 5, 6, 7, 8, 9. And then this horizontal asymptote here is going to flip and become a vertical asymptote here. So I'm going to put this little red line here. My graph almost looks like a straight line just to the side of that. And then it turns and goes down. All right, so our exponentials have two shapes. They can be going from the kind of left up, or they can be going from down to level off. All right, so those are my two exponential shapes, which means my logarithms also just have these two shapes. So they can start at the bottom and go towards the axis and then turn slowly, or they can start at the top, come towards the axis, and then turn slowly. So those are my two shapes for my logarithm graphs. All right, so quick summary, logarithms have what's known as a vertical asymptote. So horizontal, like the horizon where the sun sits, that's a horizontal asymptote, it's flat. Vertical, going straight up and down, it's a vertical asymptote at the y-axis. All right, logarithms are only on the right side of the graph. So you notice in both of these examples, my green graph has nothing over here. And this will be important when we talk about its domain, but right now you can see it's only on the right-hand side of the graph, just like exponentials are only on the top half of the graph. all the exponentials go through the point 0, 1. So my logarithms are going to go through the point 1, 0. That's going to be kind of our starting point for our logarithms. And just like exponentials, there's two basic shapes. With the bigger base, it's going to basically be a straight line up and then a curve. A smaller base is going to be a straight line down and then a curve. So those are like my two logarithm shapes. All right, so a quick example, how could we graph log base 3 quickly? Well, first of all, this is just the basic log, so I know there's going to be a vertical asymptote at 0. So I can just draw that. Again, dotted line normally, but I'm just doing it for speed and color. I can just put it as a red line. We know we're going to have the point 1, 0. And then 3, 1, and 9, 4, 5, 6, 7, 8, 9, 9, 2. But I know this number is bigger than 1, so I know it's going to be the one that starts low and curves. So I can, again, near this vertical asymptote, it's basically a straight line, slightly tilted. It's not actually a straight line because then it wouldn't be a function. All right, I get something like that. Log of 1/2 of x, again, because it's the basic logarithm right away, I can put this vertical asymptote here. This number is smaller than 1, so it's going to be one of the cases where it starts up here. And then I'm going to go through the point 0, 1 and do the little curve after that. Right, so that's how you can quickly sketch your logarithm graph. All right, here's one for you to try on your own. All right, graph log base 4 of x. I'll show you the answer in 3, 2, 1. And the graph looks like this. Main thing, 4 is bigger than 1, so it's the one that starts at the bottom and then curves up. All right, so quick summary, logarithms have two basic shapes. Again, bigger bases start at the bottom and then curve up. Smaller bases start at the top and curve down. All right, logarithms have a vertical asymptote at 0, so they're kind of this like vertical line that's keeping your graph stuck on the right side of the graph. And since our exponentials have the point 0, 0, 1, my logarithms have the point 1, 0. All right, so those are our basic logarithm graphs to know.